Okay, so this is being recorded. So what we are going to do, we are going to practice calculating the slope. And this is going to be an example problem that is just like what you would find on the handout that we're doing today and tomorrow. I'm going to sketch a very basic graph. Okay. And I am going to make this 0, and then I'm just going to go up by 2's. Yep. And then I'm going to go 3, 6, 9, 10, 11, 12. I am going to say age in years. And over here is going to be height in meters. Okay, you're going to notice frequently that I try to use 5 data points. If you use less than 5 data points, you don't necessarily see a trend, but for some reason 5 is the magic number. So whenever we do labs or activities, which I promise are coming soon, you're going to need 5 data points. So I've got 5 data points, 1, 2, 3, 4, 5. I'm going to draw a line of best fit so that we can all see it. And if I'm going too fast, please let me know so I can slow down and let you catch up. Okay. So the first thing we're going to do is calculate our slope. And then on the handout, there's some things that it's going to want us to do. The first thing is rewrite the slope. Second thing is the y-intercept. The third thing is the equation. And then the last thing is a for every statement. Yeah. For every statement. Okay. Yep. And you'll see what all of these mean in just a minute. Say again? Okay. Okay, I'm going to start calling on people soon. All right. How about Britain? Can you tell me the formula for doing the slope? That's not rise over run.
Oh, x1 or x1 or y1 minus y2 x1 or x1 minus x2.
You've got the right idea, just you haven't flipped.
Y3 minus y1.
There you go. Okay, so we have our formula. Remember, I said we're going to be using this bad boy a lot. So don't lose sight of this formula. It is critical that you keep that formula. All right, how about Luke? Can you pick a data point that might be good for the X1, Y1?
Data point?
Yeah. One of these dots.
The first dot.
The first dot. I like that first dot too. Okay, so this is x1, y1 because it is closest to the origin. It actually is the origin. So these are our first data points. What are the numbers that go with x1, y1? Lindsay, what numbers go with x1, y1? You guys are gonna find that I don't know doesn't work in here. Got best guess. Okay, where is this data point? Look at the graph. At 0. So your x1, y1s are zeros. Brandon, can you pick a data point that might work for the 2s, the y2s and x2s? Which one?
3 and 2.
You could use that one, but let's spread them out a little bit more.
9 and 6.
9 and 6, I'll take it. So we'll use this guy here. So x2, y2. So what is my x and what is my y, Ben?
X is 6 and the Y is 9.
Yes. So this guy is 6 and this guy is 9. Cool. So now we have those points identified. Now all we have to do is plug them into our formula. And I always just make my fraction line with my minuses. Yeah.
Okay, so. Sorry. I got X2.
Got what's in your numerator?
Top is Y2. Okay.
Y2. Yep.
9
Yes.
minus 0.
Nailing it.
And then
Nice
6
job.
minus 0.
Excellent.
So good.
So we are so close. So we've got 9 over 6. And then there's one more thing that we have to add in science. We have to add these units. So 9 meters over 6 years. Or 6y. Or 6, if you didn't want to write years down, you can just have 6y. It doesn't matter. So then you plug it in your calculator. You go 9 divided by 6 equals, yep. So we've got 1.5 meters. Now watch how I write this. Meters per year. Okay, so that line means per. So 1.5 meters per year. That's your slope. We're going to use that repeatedly in just a minute. Okay, easy question now. Let's go to Merrick.
Yeah.
What's my slope?
Your slope is 1.5 meters per year.
Meters per year. Okay, that's question number 1 that you're going to see a lot of times on your handout. Y-intercept. How about Ryan?
0.
Y-intercept is 0 because it crosses the line at 0. How about Kaysen?
The equation.
The equation. Do you know what the base formula is to start making our equation? And I'll get you started with y equals.
Y equals mx plus b.
You got it.
Let's go! Yeah!
He is on fire today. He had a tricky question. He got this. Okay, so instead of y, we are going to write whatever variable is on the y-axis. And I will tell you that this word is the variable, and this word is the unit that measures the variable. So what do you think the variable is on the y-axis? I'm calling on Gavin. Not a number, it's a word. The height, very good. So I'm going to put h equals, what does m stand for in math, Ella?
Like a number, I think.
It is a number, and it's about the steepness of the line. What is that number?
Slope.
It is your slope. So what is my slope?
Are you asking me?
Yep. What's our slope?
Oh, yeah, it's 1.5 meters over a year.
Meters per year. And then x. It wants the x-axis. Derek, what do you think? What do you think the variable is on the x-axis? It is age. Good. Plus, George, do we have a y-intercept? No, we don't. So we can put plus 0. Remember that b means y-intercept. So you don't really even have to write that down if it's a plus 0. Okay? So with this thing, what I think is really cool about this is it helps us make predictions. So if you've got a tree that grows 1.5 meters every year, if that tree is 10 years old, how tall should it be?
1.5 meters.
Who thinks they know? Okay, put it in the chat, but don't hit enter yet.
15 meters.
Don't put it in, okay, put it in the chat, but don't hit enter until I say 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Hit it. Yes.
15, right?
It is 15 meters. You guys nailed it. Well done. So that's what is really cool about this. So you can make that formula, and once you have that, you can make all sorts of predictions. And you will be really accurate with your predictions. Okay. When you have nothing in the denominator like this, what number do we imagine is there?
1.
A 1. This is where our for every statement comes into play. I'm going to leave a little gap. So if I was to write this for every statement, again, I'm going to use my slope. Notice how important slope has been here, 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 here. It's everywhere. So my slope is 1.5 meters per year. So for every, let me pull that up. For every 1 year, the height of the tree will do what?
Grow 1.5 meters.
Good. Grow 1.5 meters. So if you have that upward trend like we do, we know it's growing and not shrinking. If it went in the negative direction, somebody could be chopping it down, right? Taking a meter off every year. But 1.5 meters. That is a lot of information from one graph, isn't it? It's a ton. And we've got 10 questions that we're going to work on. But we're only going to do one right now. Okay, does anybody need this right now? Does anybody need more time on this? Okay. Let me go to here. Bloop. I want. Okay, this is where I want you to pull up the handout from today. Please pull up the handout that was today.
The graphing.
Yep, the graphing application.
Yeah. Yeah. No, why does it need? It's called graphing application.
So you've got graphing applications. Okay, same exact idea of what we just did on paper. If you want to continue to work on paper instead of on the screen, awesome. It's actually a lot easier if you do it on paper, in my opinion. Those of you that want to do the typing, follow along and I will show you what to do. Okay, I'm going to click this. You can either hit edit or you can double click on it and it will open. Next up, what's our next step? Hey, Shaw, what's our next step? Do you have any idea? What do I do when I have a graph? What do we start?
You find
Find a slope.
We got to find the slope. Pick a first data point that you want us to work with. Zeros. Okay, so let's go here. I am going to kind of hit the shapes, and then I'm going to hit like a little circle so I know which one I'm doing. Okay, and then I am going to go with a text box right here. And I am going to go parentheses x1 comma y1 end parentheses. And I believe Shaw already said that that was 0 comma 0. True story? Okay. Coming back over to Britton. What would be a good second data point? Make one that you can see both numbers really easy.
6 and 2.
6 and 2 is a great one. So I'm going to go with my circle again. I'm going to highlight that guy. I'm going to add a text box. And I'm going to add it above so that it's nice and clear. So this is x2 comma y2. And what were those data points, Luke?
7 and 2.
Lies.
6.
6 and 2.
Where does it say 6?
When you take this dot and you follow that right over, it looks a little misaligned, doesn't it? So 6 comma 2. Confession, it looked like that to me too at first. Yep. Okay, that's happened to some other folks today, so unfortunately you might have to write it on paper if it's not working. Yeah. Okay, next, we have to calculate our slope. What's my slope formula, Lindsay? I've called on everybody once. This is going around twice. New graph. What's your formula for calculating slope? Say that again. It should start with y something. Y2. Yep. What's in the denominator? Okay. Yes. Okay, so I highlight that and hit Control U for underline. And then x2 minus x1. Okay, Brandon.
Highlight. It just deleted everything.
No. Okay, I'll come back to you since you're making it. Ben, what do I do next? What do I do next?
Replace the X, like a Y to the number,
What's my number for y2?
6.
That's x. Careful.
2.
Okay, 2 minus
Minus 0.
0. Okay. Again, I'm going to highlight it, and I'm going to go Control U for underline. And then, Merrick, what goes in the denominator here?
It would be 6 minus 0.
6 minus 0 is correct. Okay, what units should go up here with the y's? Ryan, what unit should go there? Is it a meter or what do you think? Diameter? What do you think?
Circumference.
It is a circumference, so that's going to be in meters, and this is also going to be in meters. Okay, coming to the folks that are at home. Okay, what is my slope? Wait a minute, something's amiss here, guys. What's wrong? I see an error. Who sees the error? It's a big one too. What do you think? Is it Ben?
The 2 and 6 have to be swapped.
Yeah, this is the 6 is on the y-axis, guys. 6 is on the y-axis. So this is 6. This is 2.
I was great.
Yep. So what does that change? So that is 6 up here and 2 down here. Let's see. Kaysen, how can you simplify that?
Let's. Just look. There's 6M, and then the underline whatever thing,
Yep.
and then 2M.
Cool. All right. How about Aiden? Aiden Hunt. How can you simplify that a little bit more?
How can we simplify 6 over 2?
Yep.
Hold on 1 second.
Okay.
3 over 1. Or sorry, 1 over. My brain is hurting today.
It should be hurting today.
I didn't get much sleep yesterday.
Me neither. I feel your pain. Okay, so you had it right the first time with 3 meters.
3 over. There, I said it.
There, you got it. 1 meter.
I was up late yesterday. I had like my entire family over.
Awesome.
It was not fun.
Okay, when you guys are good with this, if you are typing it, hit save and close. And look at how nice that looks. Okay, slope. Key, what is the slope of this graph? You just got to restate it.
Sorry. This is terrible timing. I was just looking at the bathroom.
Okay, I'll go to Ryan then. Ryan, what is the slope?
3 over 1.
Okay, so I'm going to write that down here. 3 meters per meter. Okay, What is the y-intercept, Evan? Where does it cross the y-axis? How about Becca? Mason, save us. What's our y-intercept?
0.
Yep. Okay, the equation. How do we start that equation? What's our baseline thing? Can Charlie help us out?
Maybe I can, maybe I can't.
Okay, I'm going to start you with y equals.
Let's see. Y equals 3 meters over 1 meter plus b.
You're super close because he's already got the m times x plus b. So what he said was, can you restate what you just said there?
Y equals 3 meters per meter plus b.
Meters per meter. Oop. You're getting warmer. Plus, okay, b,
0.
which is 0. We're missing something right here. Okay, there's a variable that goes there, and there's a variable that goes right here. Okay, so how about, let's see, Ariel. What variable do you think goes here?
Is it circumference, like m?
It is, and we're just going to abbreviate that with a C. How about Anita? What variable do you think goes after the slope? Okay, Amber.
D for diameter.
You are correct. And then your for every statement should be for every 1 meter in diameter, the circumference will increase by 3 meters. Everybody's job is to try number 2 as homework.
Wait, only number 2?
Only number 2.